Hello everyone, this is Chinnaiah Kalpana here. In this video we are going to see a problem from partial differential equation. So let's get going. Problem: form the partial differential equation by eliminating the arbitrary constants from z equal to ax minus a by a plus 1 into y plus b. So we are asked to find the partial differential equation by eliminating the arbitrary constants a and b from this equation, right? So let's consider the given equation or the given equation as equation number 1. Now let's partially differentiate it with respect to x. So firstly we'll see the problem in detailed way and later we'll go for the shortcut just by decreasing the number of steps, okay? So I'm partially differentiating the given equation with respect to x. Just apply dou by dou x on both sides of 1. Right? Which gives us dou z by dou x equal to dou z by dou x of first term of RHS minus dou by dou x of second term of RHS plus partial derivative of the last term of RHS. Since we are partially differentiating with respect to x, so y will be treated as constant. Here we are going to use the notation dou z by dou x equal to p. Here x and y are independent variables and z is a function of x and y. We can say that z is a dependent variable otherwise, okay? Z is a function of x and y are independent variables, right? And here we are going to replace it by the notation p, since p equal to dou z by dou x, which gives us p equal to a is constant. We can write it as a into partial derivative of x with respect to x minus constant. Here since we are finding partial derivative of equation 1 with respect to x, so we are partially differentiating with respect to x, right? Y will be treated as constant. Since we are partially differentiating with respect to x, so y will be treated as constant and also a is a constant. So we'll treat this total term as constant and partial derivative of a constant with respect to x will be 0 plus partial derivative of a constant with respect to x 0, which gives us p equal to a into partial derivative of x with respect to x is 1. You'll get a into 1, which gives us p equal to a. Consider it as equation number 2. Now partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Apply dou by dou y on both sides of 1. Since we are partially differentiating with respect to y, so we'll treat x as constant here. This gives us dou z by dou y equal to partial derivative of first term of RHS minus partial derivative of second term plus partial derivative of last term. Okay, since we have a notation dou z by dou y equal to q, so let's replace it by q. We'll get q equal to partial derivative of constant with respect to y is 0 minus constant a by a plus 1 into dou by dou y of y plus partial derivative of a constant with respect to y is 0, which gives us q equal to minus a by a plus 1 into partial derivative of y with respect to y is 1, right? Which gives us q equal to minus a by a plus 1. Consider it as equation number 3. Now observe 1, 2 and 3. So by observing 1, 2 and 3 we can say that by substituting 2 and 3 in 1, the arbitrary constants a and b won't get eliminated, right? Since q has the terms involving a and p equal to a, right? So it is not possible to substitute 2 and 3 in 1. So what we'll do is, here our main motto is to remove a and b and to form a partial derivative, partial differential equation, right? So now observe p and q. We have p equal to a and q equal to minus a by a plus b. That is from 2 and 3. We have p equal to a and q equal to minus a by a plus 1, right? So just from 2 and 3 what we'll do is, right, we have equation 3, that is q equal to minus a by a plus 1, right? Since a equal to p by equation 2, so let's replace this a by p, then you'll get q equal to minus p by p plus 1, right? Now take this p plus 1 to LHS, just bring this term to LHS, you'll get q times p plus 1 equal to minus p. Okay, now simplify it. pq plus q equal to minus p. Now bring this minus p to LHS. Bring this minus p to LHS and take this pq to RHS. You'll get p plus q equal to minus pq, right? Which does not involve any arbitrary constants and is a function of pq. That is, here we have p and q and there is no arbitrary constants. So we have to get some equation of the form where it does not involve arbitrary constants, is a partial differential equation, right? In this equation we have p and q, right? So f of pq equal to 0 is our equation here, right? Which is the required partial differential equation which completes the problem. Now let's see the shortcut. Partially differentiating 1 with respect to x. Dou z by dou x, which is p, equal to a into partial derivative of x with respect to x is 1 minus partial derivative of a constant with respect to x is 0 plus partial derivative of a constant with respect to x is 0, which gives us p equal to a, right? Or in the first step you can just write dou z by dou x instead of writing p directly. Since dou z by dou x equal to p by our notation, useful notations. Okay, from this you got p equal to a, which we have considered as equation number 2. Now let's partially differentiate 1 with respect to y. Dou z by dou y equal to partial derivative of a constant with respect to y is 0 minus a by a plus 1 into partial derivative of y with respect to y is 1 plus partial derivative of a constant with respect to y is 0, which gives us, since dou z by dou y equal to q, so let's replace it by q. You'll get q equal to minus a by a plus 1. We have considered it as equation number 3, right? So now by observing 1, 2 and 3, we can say that by substituting 2 or 3 or 2 and 3 in 1, eliminate, we can't just eliminate A and B from the given equation. So what we'll do is we'll just observe 2 and 3. From 2 and 3 we can say that we can just, by observing 2 and 3, we have noticed that A equal to P, so we can just apply A equal to P in this equation, right? So we have equation 3, Q equal to minus A by A plus 1, and also A equal to P by 2. Just substitute it, you'll get minus P by P plus 1. Now bring this P plus 1 to LHS, you'll get Q times P plus 1 equal to minus P. Simplify it, PQ plus Q equal to minus P. Just bring this minus P to LHS, take this PQ to RHS, we'll get P plus Q equal to minus PQ, which is the required partial differential equation. Okay, which completes the problem. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.